let's talk about prime factorization. So first things first, well, what would a prime number be evaluated as? Well, a prime number goes by many definitions. It goes by it has two factors. It goes by only one and itself can divide into it. It goes by, what else? Yeah, anyway. So what does this mean, two factors? Well, let's take the number 7, for example. Well, 7, you can divide 1 into 7, which gives me 7. You can also divide 7 into 7, which is 1. So only 1 and itself can divide into this value. Now you might think, well, what about if I use fractions? In this case, we just want to think about integers, right? Positive integers. So we include all integers, but no fractions, right? So a prime number is pretty much a number that only 1 in itself can divide into. So what exactly is prime factorization? Well, we have this tree, and this tree has many lines. Some teachers use different methods, but this would be the one I use. So let's take the value 512, for example. So the idea of prime factorization would be to only divide it with prime numbers. So let's start. Well, the first prime number I have is 2. The second one is 3. 4. No, not 4, excuse me. 5, 7, 11, and so forth. So we want to go in this order. If 2 cannot divide into it, we look at 3. If 3 cannot divide into it, we look at 5. If 5 cannot, we look at 7. If 7 cannot, we look at 11, etc. So first things first, we're going to start with 2. Well, 2 can divide into 512. That gives me, so we work in this way. Bup, 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 bup. And then again, bup, 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 bup. Okay, that's how it would look if I had to add some arrows. So what's 2 divided by 512? Well, that gives me 2, 5, 6. I can divide 2 into this again. I'm going to go down. That gives me 128. I can divide 2 again into this. What does that give me? 16. That gives me 64. Can I do it again? Well, yes. I can divide 64 into 2. That gives me 32. Oh, this one's going to be a bit longer. So 2, go down again. 16, 2. That gives me 8, 2. That gives me 4, 2. And that gives me 2 and 2. Now, what was the idea about doing this? Well, I can now write that 512 is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 to the power of 9. And this was the idea behind prime factorization. Let's do another example. It's a bit more tricky. Well, let's look at 162. Well, I can divide 162 by 2, right? So again, we're going to move down. That gives me 81. Well, now I can't use 2 anymore because 2 can only divide into even numbers or 0. So what can I use next? Well, I can use 3. 3 would be my next prime number. It goes down. That gives me 27. Then I can do it again. 3 goes down. That gives me 9. 3, 3, 1. So what's the idea now? Well, now I can say 162 is equal to 2 multiply 1, 2, 3, 4, 3 to the power of 4. And if we evaluate this on a calculator, I can say, well, 3 raised to the 4th power, multiply 2, and that in fact does give me 162 is equal to 162. So there might be an equation where, let's look at this one. It's a, so let's use the value of 142. Well, the first one I can divide into is 2, right? 2 can divide into 142. This goes down, which gives me 71. Now, 71 is also a prime number, so it has no divisibility, which means I cannot divide with any number besides one in itself, right? So in this case, we're just going to take another 71. That gives me a 1. So my final answer would then be 2 times 71. That gives me 142. So this would be the idea behind prime factorization. It's a nice little method to have if you unfortunately don't have a calculator. But well, I hope you found some value in this video.